welcome to our project's introduction video. I'm Shana Martino and my partner is Alan Nieto. Together, we have worked on the antibiotic drug prescription project. The project definition is as follows. Antibiotic resistance is a major issue confronting healthcare providers and their patients. Changing antibiotic resistance patterns, rising antibiotic costs, and the introduction of new antibiotics has made selecting antibiotic regimens more difficult now than ever before. Our goal is to create a cross-platform mobile application that is user-friendly and can help physicians prescribe antibiotics by suggesting the proper antibiotic to use for a given patient. Here we see a Gantt chart of our project this semester. Since this was a brand new project and we started from scratch, much of the first sprint was research and setting up the project and development environment. After that, you can see we get into a regular sprint pattern. Here's a list of all the user stories that were implemented in this project. The first 4 user stories, implement login, logout, create initial user interface, implement patient information, and implement antibiotic information were all essential foundations that were necessary to build the core of the app, the rule engine. Once that was all set up, we could work on the rule engine. After that, all of our user stories were to improve, refine, and clean up the application. We'll now see the use case diagrams and sequence diagrams for each of these user stories. Since we were trying to make a cross-platform application, we decided that it would be best to have as much shared code between the platforms as possible. What resulted was a 3-tiered architecture where the UI and the application layer were split between the devices, but the business and data layer were condensed into a shared code base that all 3 types of devices could use. Here we see a minimal class diagram of that system. The doctor service provides the application layer, which differs depending on the operating system, access to the business and data layer of the application. Now let's take a closer look at the data design. Here is an ER diagram of our database. Doctors in our system have patients who are diagnosed with diseases and prescribed antibiotics. The core of our app revolves around the rule engine. This is what determines, based on the patient, what antibiotic should be prescribed. Here we see a state diagram of the process. When determined antibiotic is called, we move to the evaluate rule state. As each rule is evaluated, if it is false, then we keep evaluating. If a true rule is found, then our antibiotic is found and we return the antibiotic name. If all rules were exhausted and no rule was true, then the antibiotic was not found and we return null. This is the main algorithm of that process, evaluation of rules. Rules take the form of a string with multiple conditions, seen here. Each individual condition is separated by a double ampersand operator and takes the form of variable operator value. The first step in this algorithm is to split the condition into all subconditions based on that double ampersand operator. For each subcondition, we then break it down further using this regular expression. This will separate the condition into 3 groupings, the variable, operator, and value. Using the variable grouping, we can check if it exists in the patient knowledge base. If it doesn't exist, the rule is false. If it does exist, then we compare the value grouping to what exists in the knowledge base. If the values are the same, we return true. Otherwise, we return false. Here's a sunny day test case for this algorithm. A knowledge base that contains the proper knowledge and a condition which ought to return true are passed to the function. It is expected to return true. A rainy day test case we have is this one, which changed the rule conditions that the community acquired should be false, but the knowledge base maintains that the community acquired is true, so this condition should return false. Here are some screenshots of the automated scripts for these test cases. Here's a quick demo of our application. I'm going to log in using my username and password. Here I have a list of patients. I'm going to select Sergio. Here is his patient information. Now I'm going to prescribe him an antibiotic for abdominal infection. I'm going to diagnose him with biliary tract infection. And here we see the application has suggested that we use this antibiotic. I can click on that and get more information. Now I'm going to go back to patients, and I'm going to select Carla. Here's her patient information. I'm going to prescribe an antibiotic for her for abdominal infection and biliary tract infection as well. And here we see that the application has given us a different antibiotic. Now I'm going to log out. Thank you for watching our introduction video for the antibiotic drug prescription project.